the lowest boiling point. And remember that boiling point when you have hydrocarbons, that the more branched it is, the lower the boiling point. And why is that? It's stacking, right? So if it's very branched, it doesn't stack as well as closely together as if it's a chain. Right? And which one would be the highest boiling point? This one, right? That is all straight chain. This one is branched. This one is highly branched. Least soluble in water, right? Again, this is the ether, because these two alcohols can hydrogen bond, but the ether can't hydrogen bond with water. And then your hybridization, right? Carbon number 1 is sp3. Carbon number 2 is sp2. The oxygen is sp2, and the nitrogen is sp3. Questions? Okay, so the isomers of C8H18 with 6 carbon chains as the longest chain. And so with 8 carbons, and we want the isomers with 6 carbons in the longest chain, we're looking at hexanes, and we've got 2 extra carbons, right? So we could put both of the methyl groups on carbon number 2. We can put both of the methyl groups in carbon number 3. We can put one in carbon 2 and one in carbon 3. We could put one in carbon 2 and one in carbon 4. We could put one in carbon 2 and one in carbon 5. And then one in carbon 3 and one in carbon 4. And then the last one is your ethyl hexane. And when you're dealing with isomers, right, remember that if you are putting a branch on, a methyl group has to be at least 1 carbon in, or an ethyl group has to be at least 2 carbons in, because if you put it at 1 carbon in, then that's going to be the longest chain, and it would be 7 carbon chain. So practice looking. Hopefully by this time we've done so much naming that you have practice in finding the longest carbon chain in a molecule that is not the horizontal chain. And then your functional groups, your ketone, your carboxylic acid, your amide, your alcohol, your aldehyde, an ether, an amine, and an ester. And hopefully we've used a lot of these, and we're using a lot of these in the infrared. Hopefully by this time your structures are not so useful. Okay, we're not going to be done in the first hour, but we might be done like when we come back. So, whoops, that's 7. Mini test number 3. Okay. Energy diagram. So, endothermic reactions. A to B is endothermic. B to C is exothermic, right? Uphill, downhill. The rate limiting step is the one with the highest energy of activation, right? A going to B. The most selective step is the one with the highest energy of activation. And remember the Hammond postulate that the transition state between B and C resembles the B because it's closest in structure, or closest in energy, okay? And then the reverse, for the reverse, I could put this on here with a different color, right? Remember, the reverse, B to C is higher than, C to B is higher than B to A. So the reverse direction, the rate limiting step is C to B. Questions about energy diagrams? Oh, okay, your delta G is equal to negative RT natural log of equilibrium constant. Remember, your equilibrium constant is the ratio of products over reactants. And so this one, it was backwards, but you should be able to work stuff forwards and backwards, right? So the percentages, B over A, that gives you your equilibrium constant, and then you plug in your equilibrium constant to get your delta G. Questions? Okay. So the next one is your radical reaction. So you have the initiation step. Remember your radical reaction, you're using your fishhook arrows. Remember, for mechanisms, you have to show all the steps, all of the arrows and all of the intermediates. And please remember that arrows go from high electron density to lower electron density. In this last mini test, there were still some arrows going from positive charges. If you are doing a mechanism and you have a temptation to draw an arrow from a plus sign, resist the urge, go in the opposite direction. Okay, resist the urge to draw arrows from positive signs. Arrows go from negative to positive, or from high electron density to low electron density. So, with light, your bromine, that bond between the bromine breaks, you get your bromide radicals. The bromide radical reacts with your butane, and you can get a primary radical. That primary radical can then react with bromine to give your 1-bromobutane and bromine, the bromide radical, to continue the reaction. For the 2-bromobutane, right, your bromide radical can react with your butane with the second carbon. Your secondary radical can then react with bromine to give you your 2-bromobutane and second bromide radical. And read the question. Read the questions carefully in these mechanisms, right? And then you were supposed to circle the most stable radical intermediate. And so this was a 10-point question. So each one of these check marks and arrows and intermediates, right? Those were 1 points. And hopefully I showed that on the exam as I graded them. I tried to. That's why maybe it takes me a little longer, because I tried to show you. Except if I would have to, if I have to draw the whole mechanism for you, sometimes you'll get a little note saying, please look at the key for your homework that has this in detail. Yeah. So your stability of various configurations. Your most stable configuration for your Newman projections are the anti-configuration, and the least stable are the totally eclipsed configurations. And then for your cyclohexane, right? Remember that your most stable is your di-equatorial, and the least stable is the diaxial. And if you have an axial equatorial, right, when they flip, they're going to be equivalent, right? Equivalent energy. And then your types of strain: torsional strain, angle strain, and steric strain, right? Torsional strain, remember, it's when your bonds are eclipsed. Those two bonds, when they line up, they tend to push away from each other, and that's a barrier to rotation. And then your angle strain is how far you are from your ideal centrifugal angle of 109.5. And then your steric strain is when the two groups are close enough that they actually could interfere with each other. So, mini test number 3. Questions? Yes?
Should we go back to 5A?
5A. Okay, 4A, 5A. Yes. So, most stable is anti, least stable is totally eclipsed. Okay. And you are looking for C2 and C3, so that's how the Newman projection. Other questions about mini test number 3? So I'm going to stop here and